Well, it's a real pleasure to be here, and thank you for joining this panel about, talking about carbon management with three amazing panelists. I won't be the one telling you about, you know, um, climate change, the impact of human activities, emission of CO2. Um, we know that on top of necessary reduction of emissions, we also can leverage technological solutions to help very hard to abate and most emitting sectors. And we know that these global opportunities at the gigaton scale. So carbon removal, carbon valorization, they might go nowhere without strong downstream path, right? And so we would like to discuss today the remaining challenges for these technologies and solutions towards industrialization. What makes these emerging markets an ecosystem? And to discuss this and more, I have the pleasure to be on stage today with people that are actually building up this ecosystem, these solutions, with a very complementary approach. So Marilyn Pavan, Innovation Manager at LanzaTech, as Jim has said. So always keep an eye on emerging tech, and new partnerships for LanzaTech. Hussein Nanani, leading the partnership teams as a head of strategic partnership with a previous life on sustainability and packaging. So thank you again, both of you, to be here. And Sarah Jones, thank you for being here as well. PhD in bioengineering, a former life at an accelerator program, but today investing pre-seed, seed in climate startup at Zero Carbon Capital. So, and actually, Sarah, turning to you. So before diving into this carbon management and looking at the value chain, it would be quite interesting for you maybe to set the scene and go maybe beyond the buzzwords. We're going to talk about CDR, DAC, CCUS, and carbon credits. Can you elaborate a bit on that and give us a bit of context?
Yes, happy to. So thank you so much for having me. So I want to set the scene a little bit by saying that life on Earth is carbon-based. And most of our modern life relies on carbon-based chemicals and materials. So, of course, we've caused this problem of extracting fossil fuels, so ancient stored carbon, and releasing that into the atmosphere. So when we talk about decarbonization, what we really want is rebalancing carbon. So for net zero, we want to achieve the amount of CO2 being released, the same amount to be captured. So it's really great to be on stage here with both Climeworks and LanzaTech coming from different angles, because we need both carbon dioxide removal, so taking atmospheric carbon dioxide from the atmosphere and storing it durably, but we also need to find feedstocks for our carbon-based chemicals and materials. So that's what I think we need to be thinking of in terms of carbon management.
Yeah. Thank you, Sarah, for this introduction. Maybe Usain, at Climeworks, you are actually doing carbon removal today with your DAC technology, and which I guess you couple with deep storage, maybe in aquifers or depleted oil fields, I guess. But we know that this activity is highly dependent maybe on carbon credits. And so I would like to get your perspective on this market. Is there a market today? Is it an emerging market? And maybe looking at the demand for carbon removal across industries.
Yeah, for sure. I think you can hear me. So starting first of what we do at Climeworks, I think it's interesting to first explain. So we use large machines to remove CO2 from the air and store it permanently and safely deep underground where it cannot escape anymore. So as an analogy, it's basically a vacuum cleaner for CO2. That's how you should see it. And today we work with large corporations, namely Microsoft, JP Morgan, Boston Consulting Group, Swiss Airlines, but we also work with smaller companies like SMIs, but also with individuals, Bill Gates, Coldplay. So we have roughly 150 partners in the world today, and that are partnering, most of them, with long-term partnership with us to remove CO2 from the air as a service. And if you think about it, today, what Sarah was also saying, we need large amount of CO2 to be removed from the atmosphere. Nature can do a lot of that, but nature cannot do everything. So we need to have now tech to complement nature. And we are now building this technology. Today, we've built the biggest and first direct air capture plant in the world in Iceland, fully powered with renewable energy. And today, the way it works, if I can just quickly explain, because people may think it's a science fiction when you remove CO2 with a machine from the air. Imagine a large fan that pulls air through it. Inside that fan, you have a filter, a chemical filter, a solid chemical filter that attaches CO2. Once that filter is full, you close the fan and you apply waste heat to remove that CO2 from the filter. And once we have collected that pure CO2 as a gas, we can store it, like you mentioned. The way we store it, for example, in Iceland today is we are injecting it into the Icelandic basaltic rock with a partner company called Carbfix. And actually, I can show it to you here. This is nobody can see it, but later on I can show it to you closely. You can see it maybe on the video, yeah. So this is a sample of a sliding basaltic rock, a kilometer underground, and the white dots that you see is carbon capture from the atmosphere that solidifies underground. And that's how you permanently and safely get rid out of it.
Amazing, thank you. And maybe following on that, do you plan, or are you today doing, valorizing this carbon you capture instead of storing it? Maybe you have a point of view you'd like to share about, deep storage versus utilization for chemicals or jet fuel?
So today, our first priority is to scale direct air capture and storage to reach the capacity of 1 million tons by 2030 and billion tons by 2050. To give you an order of magnitude, the numbers that we need to remove in 2050 will be in the range of 6 billion to 16 billion. Climeworks will do 1 billion out of that. So we need to scale that rapidly also for the planet and for the companies that will need that amount for their removals. Now, when it comes to utilization, as we scale and as our capacity increases, there will be a stream for utilization. We've done that in the past, and we can still, we can do that. Like the first pilot plant we had was in Switzerland, and what we were doing is we were capturing CO2 from the air and using it on the Coca-Cola bottles. So it was a pilot to really show that there was a commercial use for captured CO2. And if you think about it, also one of our latest partnership with Swiss Airlines, we agreed that in the short term, we're going to have carbon removal services to remove their hard-to-abate emissions. But in the long term, as our capacity grows, our CO2 could be used for biofuels as well. So then they can also create sustainable aviation fuel and reduce also their emission once we get to proper scale.
Thank you, Usain. And Marie, I guess you have a lot to add to that. So at LanzaTech, your position more downstream, right? And maybe you can tell us a bit about, help us understand better your position in this emerging market. So can you, maybe before, share a few words about the tech, of course, but I'd love to know indeed about, your biofermentation process versus more classical Fischer-Tropsch processes. So yeah, to produce these kind of liquid hydrocarbons.
Yeah, sure. Good morning, everyone. Thank you for having me today. So yeah, let me give a little background about the technology. So LanzaTech has it's a gas fermentation company. So I would like you to think about a fixed portion of the process, which is the bioreactor. And this fixed part of the process allow us to be more flexible in the inputs and outputs, and I'll be more clear about that. So LanzaTech has this microorganism, is an anaerobic microorganism from the Clostridium family. And this microorganism, instead of sugars as yeast does fermentation, it uses gases, so CO, CO2, hydrogen, to produce primarily ethanol. So we have this bioreactor that is completely tailored, specific for this microorganism. Gases are more difficult to dissolve than sugars, so it has to be very specific for this process. And then the inputs can be either off gases, like industrial off gases, that otherwise would go to the atmosphere, or it can be solid waste that we can gasify, like municipal solid waste, agricultural waste that we can gasify and feed the microorganism with it. It can also be CO2. If we have like a source of energy, it can be CO2 as well. And then this microorganism produces ethanol. Primarily, we have a big synthetic biology group in Chicago working to modify this microorganism to produce other things other than ethanol. And we have isopropanol, acetone in a pre-commercial phase. And we have already 3 commercial plants in China and 1 in Belgium with ArcelorMittal. And we have also a plant being deployed in Japan with gasified municipal solid waste. So it's getting, and we are deploying another one in India as well. So it's really a proven technology to recycle carbon. Compared to the Fischer-Tropsch, because it's a biological system, it is more flexible, more robust. So it can tolerate impurities. It can tolerate fluctuations in the gas composition and the gas quantity that you feed the microorganism with. And then, in this sense, it can keep the high selectivity for the product that you are producing. It also, it doesn't need to be as big as a Fischer-Tropsch kind of facility. So our idea is that we can that we put this bioreactor in the same site where the feedstock is, reducing the costs and being more global and be more decentralized than the regular kind of processes. So that's like a summary about what we do and where we fit in this carbon market. I also brought, so again, it's a proven technology. We are producing large-scale, commercial-scale ethanol. And I brought 2 products here. One is the Zaradress.
So not just ethanol.
Yeah, so this is the Zaradress. It's been sold in Zara stores, and it has like a tag saying that it's made out of carbon, recycled carbon. So ethanol can be a lot of different things. It's a building block, a chemical building block. So we can make polyester, for example, with it. We have also partnerships with Gucci to produce perfumes, also in the stores, and with L'Oreal as well to produce packages. And I have another one here. It's a Craighopper's fleece. There's also a tag here. No, I guess it's fine. There's also a tag here. I don't know if you can see it. Yeah, saying that it's made out of recycled carbon. So yeah, that's basically what LanzaTech does.
Thank you very much, Marlene. And actually, maybe I can, ask you. As you see, Sarah, LanzaTech Climeworks, they are tackling this global challenge in a very different way. And I'd love for you maybe to share your insight as an investor, what you've seen the trends are. Is one type of solution, does it have more traction than the other? What's your take on that?
Yeah, happy to share that. So far, I've seen more of a focus in sort of volume of startups and investments in the CDR, so that's the carbon dioxide removal space, and it's been over a shorter period of time as well. So at $100 per ton of CO2, this is a $1 trillion market, and because it's a new market, it's sort of wide open in terms of innovation. So there's been an explosion of startups and investors into this space. On the investment side and the venture capital side, it's a lot been going into DAC, or direct air capture, because there's strong defensibility and scalability with that. But there's also a whole lot of other CDR technologies. So there's biochar, there's ocean CDR approaches, alkalinity enhancement, etc. So there's really a lot of innovation in that space. And in terms of the carbon product side, that it's been sort of a longer timeline. So Cleantech 1.0, already there were sort of biochemicals and biofuels and that sort of thing. And there's been some successes and failures over the years. I'm still seeing a lot in that space still. So in terms of sort of technology areas that I think are interesting, just to go back to the CDR side, so there's biological CDR, which are usually low cost, but often the measurability and durability are lower. And then on the engineered side, so that's where the direct air capture is, usually great measurability and high durability, but tend to be high cost, usually because of the high energy requirements. So then on each side, there's room for innovation. So there's room for improving the durability, and people are working on solutions for MRV, which is the measurability. But there's also a lot of focus on reducing the cost of direct air capture, mostly focused on reducing the energy requirements. So it's a bit cheeky to be on stage with Climeworks and say that I think electrochemical DAC is actually really interesting, a really low energy approach. So we've invested in a company called RepAir who do modular direct air capture using an electrochemical approach. And then on the carbon product side, there's a lot in the e-fuels and e-chemical space, so a lot of startups working on that. I think we need to think carefully about that. So they're really high energy solutions. The direct air capture is high energy. Carbon dioxide is a really stable compound, so to break it apart and turn it into other things takes a lot of energy as well. So we really need to be thinking about other types of carbon feedstocks also. And then I had a quick look at stats on hydrogen electrolysis. So obviously, if you use carbon, direct air captured carbon, and then you want to make hydrocarbons, you need a hydrogen source as well. And just as an example, the 2050 demand for methanol, the amount of hydrogen you'd need would take about 14% of the world's electricity. So it's a huge amount of energy for these sort of e-fuels and e-chemicals. So they probably have a role. But I find it interesting thinking about what other carbon feedstocks are interesting. So there are a lot of companies working on plastic as a carbon source, so recycling plastic back into its monomers and into chemical precursors. And also biomass is an interesting source. So there's biomass means plants, biomass waste, microorganisms. So we've invested in a company taking lignin waste to BTX chemicals, which are particularly difficult to make from carbon dioxide. And then also on the microorganism side, algae take up CO2 from the atmosphere. And so we've invested in a company, Phycobloom, that takes algae and converts it to sustainable aviation fuel. So those are just some examples of the things we're seeing in terms of startups.
Thank you. Thank you. And it's actually amazing to see the diversity of technologies and solutions that are being developed. Even direct air capture is not one type of technology. You have all of these work on new solvent, the way you then get the carbon out of your trap, whatever it is, chemical or not. So it's very amazing. But more often than not, what we see is that the big challenge for these companies is to get to this first of a kind demonstrator, this first step towards industrialization. Many of them are maybe not there yet, right? And I'd like to see how you could maybe give us your insight as an investor, how this investor community supports this wave of innovation towards these first of a kind demonstrators.
Yeah, so it's definitely been identified. So first of a kind financing has been identified as a real gap and a real problem. But I've seen certainly over the last year a lot of people mobilizing to solve this problem. So a lot of people having conversations in the VC community. Of course, there's Breakthrough Energy Catalyst, who fund the large demonstration and first-of-a-kind financing stage startups. But there are also some new funds emerging who, sometimes have combinations of growth equity and project equity, and they're people being innovative and looking at new models for financing the stage of company. There's also a role for government. And Zero Carbon is part of Cleantech for UK, which is the sister organization of Cleantech for Europe. So that's a coalition of venture capitalists who are advocating to government. And one of the important topics that we're discussing at the moment is exactly this, like how government can get involved to support and pave the way for clean tech in terms of financing. So there's conversations about blended finance models, possibly government as a guarantee, a cornerstone guarantee, and blended finance models. So with government there and then attracting in more private capital. So I think that's all really interesting. And I think there's a panel discussion at this conference later on that.
Indeed. Thank you, Sarah. And Mari, would you like to share a bit maybe the journey of LanzaTech towards industrialization? Maybe, what are your insights on that and your take on what Sarah just talked about?
For sure. So first, you have to be very clear about your strategy, your model. So since the very beginning, the company wanted to have biology and engineering side by side since the very beginning. So you have to consider all the challenges that you are going to face at an early stage and not solve a problem at the time. As I told you, the biology, the microorganism, the system, the gas fermentation system is very specific. So if we didn't have the engineering team working in the specific bioreactor for that, it wouldn't be economically feasible, as efficient as it is today. So your strategy has to be very clear. You have to consider all the challenges. In terms of strategy, also we were always mindful that we wanted to be very flexible in terms of feedstock that we can use and the product that we can produce, so we can attend different demands and be in different geographical locations as well, to be where the feedstock and the demand are. But we wanted the bioreactor to be fixed because it's probably the most expensive and challenging part is the scaling up of these technologies. So if we were to produce or to build a new bioreactor every time we wanted to produce something new, it would be very challenging and very expensive. So the way that the reactor is built today, you can just change the microorganism in the reactor. So you can change from ethanol to isopropanol and start to produce something different very easily. So it attends the demand of the market and the consumers and our partners as well. Another thing, it takes time, of course. The first commercial plant was deployed after 15 years after the company was founded in New Zealand. It takes a lot of money and investment. There's no miracle. And also, it takes a lot of data. We collect data since from the laboratory, the proof of concept experiment up to the commercial plants. We are always collecting data and analyzing them to make the process. We have a dedicated artificial intelligence group that is dedicated to collect and analyze this data to make our process better with the time. And also, finally, what we understood since the very beginning as well is that it takes, for these complex problems that we are trying to solve and these technologies that we are trying to develop, it takes a diverse team as well to think, to bring to the table all the different visions and expertises and backgrounds to solve this kind of problems. So I would say that these are the main things that we learn in this process and that we can communicate to other companies in the same path.
Thank you. Thank you. And you say maybe what about Climeworks? I know that you're moving from Orca to Mammoth, even though I always thought that an Orca is bigger than a Mammoth, but tell us about that. No, yeah, what's the insights you could share us on this journey as well for Climeworks?
Yeah, I mean, DAC challenge is quite often getting out of the lab into the real life. So we went to the real life in 2017 in Switzerland with the plant that I was mentioning that we were doing utilization. And then we opened Orca a few years later, which was the first commercial plant for storage. Yeah. And that was 4,000 tons roughly per year. So it's still a small one, but that was to enable us to collect data, sensors, to really make sure that we understand how to operate in different weather conditions. Just a little anecdote. The first winter we went to Iceland, it was maybe one of the worst winters in the last 10 years. And if you imagine that we have fans pulling out air, but if instead of air, snow is coming horizontally into that, then you really need to make your technology resilient. So you learn like that out of the lab. You also we were in the middle of a very big supply chain crisis at that time. So if a part breaks, it was very difficult to get that replaced fast. So that helped us really operate in real life and build what we're now launching this year in a few months with Mammoth, which is 10 times bigger, which is going to be, after Orca, the world's largest plant for direct air capture and storage. And with all of those 120,000 hours of operating, we can really now improve at every step. So the way we're thinking about it is deployment-led approach. Start with one, learn, and then make a jump. So that's what we did with Mammoth, which is our second plant. We jumped 10x. And that's how we're seeing it as we move towards million-ton capacity. So we have projects in the US. So we are working, we've been selected by the Department of Energy to potentially receive a grant that is in the range of several hundred million, 600 millions, to build a plant. So that also enables us to now come with the technology that has been proven and that we can scale much faster to 1 million ton. We are working also for a project now in Kenya. So how can we go to other conditions and also do direct air capture? And also Kenya is a very interesting location in terms of energy that is abundant when it comes to geothermal, but also storage, the same way as in Iceland. You can store it into the basaltic rock. So all of that approach really helps us, scale. And if you think about it, the last important thing is we are building an industry. I mean, you mentioned it, it's going to be $1 trillion, right? So it's not just anymore a plant for demonstration. It's now we're rolling up globally this industry. Some people say that by 2050, we need 1 million people working in that industry. So it's not anymore a climate impact that we need to look at. It's a whole economical impact as well, right? So if you're going to a plant we're going to build in Louisiana, we will create a lot of jobs. So we need also to make sure that those jobs are, helping the ones that needs the most. When we go to Kenya, we really want to leverage the local workforce and to build that industry. And we're also, let's say, thinking, okay, how will you reskill the people? Because if you're going to get 1 million people working in that industry, and not only at Climeworks, you need to find the right ecosystem to build it. So these are really the challenges ahead of us, and moving out of the lab and really making it a proper global industry.
Yeah. Thank you. And I mean, we touched it a little bit about, in a way, the levers, right? About what's necessary out there for these technologies to thrive. And I know that on top of financing, and we can look at these, the big news, I think it was last year, about the frontier market commitment of $1 billion from big tech players. I mean, what are the other, drivers and policies that you see are necessary for CDR to scale? There's, of course, this American Inflation Reduction Act with these $3 billion tax incentives. But yeah, can you tell us more, maybe you saying on that?
Yeah, for sure. I think if you want to make a real climate impact and build that $1 trillion industry, it's going to be, of course, more than one thing. But you really need to think about it like a systemic push. The first push is really the offtake growth. So let's say the corporates making early, large, sizable, and long-term offtake commitments are helping us scale much faster. And if you think about it, we had, you've mentioned Frontier, we also have several, let's say, important agreements signed last year when Boston Consulting Group did one of the longest commitment until 2040 when they want to be net zero. So this commitment really helps the industry to scale. And that's the first engine of that push. Actually, even I think a few days ago, Google also announced that they will do a major investment into CDR in the next 12 months. So this is really helping us. The second one is policymakers, right? So you need to create the right framework and you need to create the right subsidies and incentive from the policy side. So the IRA in the US was a game-changing, let's say, approach for that industry, creating DAG hubs with an overall investment of $3.5 billion. And also we're now seeing more and more, let's say, evolution. Last month in the EU, there was a lot of improvement when it comes to the right certification for carbon removal, the right utilization of engineered removals, namely for tackling fossil fuel. So those improvements are really, really helpful on that side. Then, of course, we need even more, right? So we need investors. The role of investors here is really to help us pre-finance our plants, right? Because those are going to be, let's say, a large investment up front and then needs to come to life, right? Mammoth take almost 2 years to build, right? So, of course, the public sector is helping. The IRA has a big also investment into that, but this is a big part of the equation. And I think the last one, which is quite often unsuspected, is really the suppliers. Because even if you have the money, the subsidies, if the supply chain is not ready, if you don't have a mass industrialization supply chain, then you cannot start. So that's where the supply chain is critical, right? If you're going to build a 1 billion ton capacity in 23 years, or now, I mean, in 2050, imagine that today the capacity is 50,000. So if you go to a supplier and you want to build a 1 billion ton, they need to get ready. Yeah. And to get ready, it comes also by seeing that the corporates are committed, that the governments are committed, and then the supply chain follows. But if the supply chain doesn't follow, you're never going to be able to scale at the speed that we need to.
Yeah, indeed. And Mary, on CCU, because I know that this American Inflation Reduction Act also gives huge incentives for sustainable aviation fuel, I think. But do you see also other maybe initiatives similar in Europe here or in the rest of the world, maybe?
Yeah, absolutely. Actually, it changes a lot, right? Depending on the country and the region, the policies that are out there. But I guess in general, what the governments are figuring out is that they are a very important piece in this process of getting these technologies out there via or financial incentives or better policies or building infrastructure as well for, in our case, for fermentation. So there are a lot of different initiatives like Biomade in the US, building infrastructure for fermentation that others can use, startups, other companies can use. I know that this is new in the US, but it's something that Europe, it's ahead, having decentralized fermentation facilities. The way that you put policies in place, it's very important as well. These policies have to be agnostic in terms of the technology and also in terms of the molecules that you are producing. And it's not true in some cases. In the US, we face some challenges in terms of gases, waste gases to be considered like bio. So it's not agnostic. These policies are not agnostic in this sense. In other regions, it's about molecules, what molecules are more interested to their region. But at this point, we need all the solutions and all the incentives possible, so being more agnostic in this sense. And these investments come from the government. I would say that it's like a common ground for all regions and technologies.
Thank you. Well, as our time is running out, this is also the topic of the summit itself, right? And I would like for us to have a bit of time looking at the questions from the audience. And thank you again for sharing your questions. One a bit, let's see who wants to take this one. But with all these CDR technologies out there, who needs to worry? I mean, right? It's listening to all of us, apparently. When these technologies reach full scale, the CO2 cycle will be fixed. So, I mean, Sarah, do you want to take or maybe tell me?
Please
yeah, Sarah, you want to take it? I saw two movements with the mic, but...
Okay, I'll go first and then Hussein. So first of all, we're currently, our CDR capacity currently is 2 gigaton per year. and we need to get that to 10 gigaton. And most of that 2 gigaton is reforestation. So we're talking about these amazing DAC and all these other CDR approaches, but they aren't scaled yet. It's still a tiny amount relative to what we need to be doing. So it's still a huge endeavor to get that to the scale that we need to meet our targets by 2050. So that's the one piece. And then I think I really like that this panel title is carbon management, because we really need to think about the fact that even CDR, it's still resource constrained. So it's not a sort of magic thing where now we're going to build billions of DAC facilities and that's just going to solve all our emissions problems. It's high energy, it's land use restricted, sometimes uses a lot of water. So we have to think about CDR as a constrained resource. And so we need to be using it for only the hard-to-abate emissions and for drawing down carbon, historical emissions, to get us back, at least to 1.5, and hopefully in the future better than that. So, yeah, I don't think it's a magic solution, and there's a lot of work still to be done.
Thank you, Sarah. Do you want to add something?
I agree, and if I can add, so people often ask us, is it a silver bullet? No, it's not a silver bullet, it's a silver buckshot, and it's one of those. Now, think about it, right? There is today in the atmosphere 40 billion tons of CO2 emitted every year. If we don't do the reduction, and reduction is priority number one, to reduce to 90%, that's what science is telling us, then only 4 billion tons will be left, ideally. These are the hard-to-abate emissions. That's where CDR comes to play. And what I said is we are trying to get to 1 billion tons. So out of those 4, 1 billion will come from us. So that means this cannot be a reason not to do the reduction. That's going to be for the hard-to-abate. And once we tackle the hard-to-abate, that's where we go back in time in a way, and we start removing the historical emissions with CDR. So I think that's very important, right? It's never going to be the silver bullet, but you need to bring them at scale, and I think that's the important message. And think about it, like you need to. What it means also is that companies today need to start thinking on one side, how do I accelerate my reduction, but how do I start thinking about my removal strategy as well? So it's not going to be after, because you need to also have both ready on time. So I think that's what I think people need to also remember out of that.
Removal cannot be the only solution. We need reduction, we need the right reduction, we need to replace some of our fossil fuel usage, and we also still need to work on the efficiency of some of our systems that maybe
and if you think about it, and back to what Sarah said, it's also not economically viable.
Yeah.
Because if you start using all the money to remove what you have, even if you had the capacity, it doesn't make sense. You will eat more than a solid double digit of global economy, GDP, if you do that. Yeah. But if you only focus on the 10%, the hard-to-abate, then you're getting closer to 2% of global GDP. That is actually how much the world is spending on waste management. So you can think of, okay, that could make sense from an economical standpoint. But if you really see it as a way to take care of the problem, no, it's not.
And maybe a question also from the public to Marie on LanzaTech. On your biofermentation process, you have inputs, as you told us. What's the ecological, environmental impact of these inputs? I mean, if you don't source them the right way, it can be counterproductive, maybe. So can you tell us a bit more about that?
Yeah, absolutely. That's a really good question. So if you compare the process, first we are recycling this carbon. So we are avoiding mining more fossil from below ground. So this has a huge impact, as Sarah was saying at the beginning, in the carbon balance. So when you compare, and we have a Nature publication very recent out there, comparing production of isopropanol and acetone with the fossil part of its production, and it's like we actually in our process we not only are abating these emissions, based on what it would be producing from fossil fuels, but we are actually being able to lock some carbon in these products and retarding the time that they take to go to the atmosphere. So it's compared to the fossil production is like an abatement of 80%. It's, and in some cases, like isopropanol, for example, it's actually that we are locking some carbons, and so it's actually negative.
Thank you. Well, I mean, we do have other questions from the crowd, but I know that you will stick around at the summit and enjoy the booth, the other content on this stage and others, and so please don't hesitate to go directly talk to Usain, Sarah, and Marie to have their take and continue the discussion. Maybe for the 5 minutes we still have left, a minute or so of conclusion from you all, and maybe, Sarah, a conclusion, maybe even a call to action?
Yeah, sure. So at Zero Carbon, we think about an ideal 2050 vision. So not things that will get us partway there, but things that will get us fully to an ideal 2050. And I think it's important to think about efficient ways of getting there. So, you know, what are the best ways and what are the most useful and efficient places to use CDR? So, you know, worst case scenario is using DAC to remove emissions from fossil energy, for example, when we know that there's affordable renewable energy. So my call to action is really for people to think about efficiency, think about where to use things, and also to think about where to source carbon from. So there's an efficiency play there. And think about how to prioritize different carbon feedstocks so that we're all in line and on track for net zero 2050. And yeah, more than anything else, I want us all to solve the climate crisis. So I really hope that there's some smart people thinking about this, thinking about it pragmatically, the huge challenges that we have to solve still, and above all, who are really ready to be proactive in solving them. I think we all as a community talk a lot about the problems and think a lot about what could be done, but now is really time to act. So
one of the mission of Hello Tomorrow, indeed. Thank you. And Marie, do you want to say a few words?
Yeah. Again, thank you for attending this panel. We as humanity, we are facing one of, if not the biggest problems in our society, which is the climate changing. And we need all the technologies, all the support, all the partnerships to get these technologies that can make a dent in this challenge out there. And what was very recently thought as impossible, now it is possible and is being commercialized as better solutions for our carbon economy. And we don't have time to waste, so the time to get these new technologies and these new solutions out there is now.
Thank you, Marie. And Usain, I'll leave the last words to you.
Thank you. Two last, let's say, message for me. The first one is, again, to reinforce this, and mainly maybe for corporates, the priority is to make sure that emission reduction is done, and that's the 90%. That will always be the first priority. And then for what's left, then that's what removals come to play. But I encourage everybody to start thinking not only about the reduction path, but also the removal path. And also thinking about it, since you're a corporate, economically as well, right? Because this is not only, let's say, a planet discussion, there's also an economical discussion also to have here. And I think it's important for you to assess what is the cost of being, what is the advantage of being the first mover? How can we quantify the first mover advantage versus the cost of inaction? Today, the examples that I was showing of companies today moving are also gaining the first mover advantage. I mean, we can talk more about what that advantage is. And also, what is the cost of inaction? I mean, we heard a lot about lack of supply in a few years. We heard about more regulation coming in. So I think it's important to have this understanding. And last analogy, especially for the lack of supply, when in Switzerland, where I live and where I come from, we often compare it to winter and winter tires. You're not going to buy your winter tires the day it snows. You take care of that before. So if you need your supply in the future, you need to kind of prepare for that. And I think that's what I will leave it as the last word. A winter message on the beach.
Exactly. Thank you very much. Thank you very much, you three, Sarah, Mary, and Usain, for your time, for your insights. I really appreciated this discussion. I hope the public did too. Please enjoy the rest of the summit, and see you soon outside of the stage. Thank you very much.
Thank you, Vincent.
Bye-bye.